Hello students. So today we are gonna see how to calculate bond order of a molecule without drawing the molecular orbital. So let's see. Now we are gonna see a table. In the table, we are gonna see that if number of electrons is given or we calculate the number of electrons, we can just conclude its bond order without drawing the molecular orbital, and also can tell it's diamagnetic or paramagnetic. So let's see. First is number of electrons, then our bond order, then magnetism. Okay, then we are gonna start from 14, a number of electrons, then its bond order comes 3, and magnetism comes diamagnetism. Now if we increase one electron, then its bond order gets less 0.5, and it's if we decrease one electron, it's also bond order gets decreased by 0.5. So let's see. First is our 13, that is one electron less, so its bond order gets less 0.5, and its magnetism come paramagnetic. Now for 12 it's 2, and it's diamagnetic. 11 also gets less 0.5, that's 1.5, and paramagnetic. 10 1 paramagnetic. 9 0.5 paramagnetic. 8 0 diamagnetic. Now if we increase one electron from 14, then this bond order gets less 0.5, that is 2.5 paramagnetic. 16 2 paramagnetic. 17 1.5 paramagnetic. 18 1 diamagnetic. 19 0.5 paramagnetic. 20 0 diamagnetic. Now you can see that if number of electrons is even, it comes diamagnetic, and if number of electrons is odd, then it comes paramagnetic. Just like you can see that 8 gives diamagnetic, 9 gives paramagnetic, 11 gives paramagnetic, 12 gives diamagnetic. But there are two exceptions in this table. That is, first is our 10. You can see it's even number of electrons, but its magnetism comes paramagnetic. Also there is 16, it is also even number, but its magnetism comes paramagnetic. If we just take these two exceptions, all the other magnetism are just like that. If the number of electrons is even, it comes diamagnetic. Number of electrons is odd, it comes paramagnetic. Okay, that is for O2, number of electron is 16, right? Total number of electrons, so its bond order will be 2, and if it's O2 plus, it will be 15, 2.5, because one electron is less here, right? So O2 plus will be 14, because another electron is less, so its bond order will come 3. For O2 minus, it is one electron excess, then 16, so it's come 1.5, and O2 2 minus, it's 18. So here its bond order come 1. So this is the order of the bond order for O2. It is O2 2 plus greater than O2 plus greater than O2 greater than O2 minus greater than O2 2 minus. Okay, now we are going to see some exceptions. Okay, let's see here. That is bond order of N2, that is number of electron is 14, bond order is 3. Then N2 plus, number of electron is 13, bond order comes 2.5, and then N2 minus, number of electron is 15, bond order comes 2.5. Now for N2 plus and N2 minus, their bond order are same. So how we are gonna write its bond order series then? That is, in N2 minus, there is one electron in the anti-bonding molecular orbital of p, 2p. So what is that? That is, if we draw the molecular orbital of of 2p here, okay, as you can see, that is, we are drawing it for N2 first, then we are going to draw it for N2 1 minus. Okay, so as you can see, the bonding molecular orbital is already filled with 6 electrons, right? So where will be the excess one electron will go for N2 minus? That is our antibonding molecular orbital. So if a electron is present in the antibonding molecular orbital, what happens? This increases the energy for this N2 minus, and if the energy is increased, then the stability is less. Okay, so energy increased, stability becomes less, stability decreases. So this N2 minus is bond order will be less than this N2 plus. Okay, so remember this, that if the bond order comes same, then we see the number of electrons in the antibonding molecular orbital. If there is one or two antibonding molecular orbital electron is present, then its bond order becomes less. So if we write its bond order series, then it will be N2 greater than N2 plus greater than N2 minus. Okay, so let's see the next part, that is bond order of CO and NO, because these are exceptions. So for CO and NO, there is the exception, that is the 2p orbital here overlaps. Okay, so let's see how that happens. It is the see, that is how this is a s orbital. Okay, but it gets overlapped, right, like this. So what happens, all the electrons are occupied here, right? So over here we can see for CO, C has this 1s2, 2s2, 2p2, right? And O has 1s2, 2s2, 2p4. Then what comes? That is 14 electronic system then. Okay. So if we just fill the electrons here, that will be like this, right? So what this comes? Bond order, that is half into 10 minus 4, that is our 3. But here is an exception, that is for bond order of CO plus. So what happens in case of CO plus? That is bond order comes 10 minus 3, and it will be 3.5. It's bond order formula, because I have shown the overlapping in the previous figure. So it will be bond order of NO. But what happens in case of NO plus? Because it frequently asked question in NEET. So it comes 10 minus 4, that is our 3. That is, if bond order is positive, then only the molecule exists. Okay, then if bond order is 0 or negative, it doesn't exist. That is example given any 2, that it doesn't exist in real life. And if the bond order is fractional, then it's paramagnetic. If the bond order is whole number, it can be para or diamagnetic. Or bond order of single bond is 1, then bond order of double bond is 2, and bond order of triple bond is 3. Okay, that is bond order is directly proportional to bond energy, then directly proportional to ionization energy, inversely proportional to bond length, directly proportional to electronegativity, directly proportional to stability of the atom, and also directly proportional to the dipole moment. Okay, then let's see some examples of the proportionality. That is bond order of O2 series is O2 2 plus greater than O2 plus greater than O2 greater than O2 minus greater than O2 2 minus. So what will be the bond length series of this? That would be O2 2 minus greater than O2 minus greater than O2 greater than O2 plus greater than O2 2 plus. Now see, let's see some stability series. That is bond order of N2 series is our N2 greater than N2 plus greater than N2 minus, right? So what will be its stability order? That will be N2 greater than N2 plus greater than N2 minus, because stability is directly proportional to bond order, right? So that's it.
To learn difficult concept of physics, chemistry and biology within few minutes to crack NEET and JEE with fun, like, share and subscribe our new YouTube channel ShantU. You will get conceptual videos, highly effective notes, short tricks, mock tests and much more. Hope we shall meet there.